Okay, so good morning, everyone, and thank you for joining us today. This is going to be our second meeting for the wheelchair testing centers. So before we continue, I would like to just give you some indications for how we're going to continue on our meeting. So I would like to please ask you to go ahead and rename yourselves. So to do that, please click on the bottom bar. You're going to see participants, and then go to your name, click more, and then you want to change it to your name, then the country, and finally the testing center that you join us from, okay? So I will give you guys a couple minutes to do that so we can all see where we are. And if someone has any problems doing this, please let me know. Um, okay, looks like we're getting close. So thank you. Now, if you need to send any message to the group or to someone in a specific, please just go ahead and click chat and you will be able to see to everyone or select the user that you would like to contact directly. And finally, as you may already know this, we have different views on Zoom. So you can check on those little dots and change the views from gallery or to speaker. And you will always see that small square around the person who's speaking or the loudest person, okay? Finally, at the bottom, you will see the toolbar that we just used. And with this, we can start with our agenda. So for today's meeting, we're gonna start with a quick welcome to all our centers, and I'll be giving you some wiki updates and also with the wheelchair testing centers. Then we will have the presentation of the test dummy setup that will be from Bill Ammer, who is from Ammer Consulting. And finally, we will be sharing some questions from a new testing center. I will be explaining how that worked in the presentation later. And finally, we will open room for discussion and we can all participate then. Sorry, I just got. Are we recording the session just to make sure we are? I think we are, yes. Okay, thank you for the reminder. Okay, so with this said, we are creating this wheelchair testing centers group to first promote all these centers. So we want to make sure that the entire world is aware of where they can go and who that they can contact, and also what are the testing that's happening in different locations. So with that, we're also looking to serve as a resource for wheelchair testing centers, new testing centers, and that can also help to different manufacturers, designers, and researchers who are trying to improve the quality of wheelchairs. And with this, we can also create a community of practice, such as the one that we are doing right now. And I would like to thank all of you for being present today. And I think that what is important is for us to continue to communicate and keep the communication going. Now, as part of our kickoff meeting in April, we were able to have participants from multiple countries, such as France, Brazil, the UK, the USA, and we also got Sean equipped from I'm sorry I didn't include your logo. I don't know why I missed it. I'm sorry about that. And also we got it from Kenya. So we also got a representative from each of these testing centers. So I would like to really thank all of you who shared your pictures from the facilities, and also we'll learn what are some of the testing that's happening here. And with that, I also got in touch with new members after a meeting, and some of the centers that we received the form from as well. And with this, we found a new testing center. This is Carlos Costa from Universidade de Caxias do Sul. He is from Brazil, and he is a PhD who completed his PhD in the UK. I'm not sure if Carlos is here yet, but he said he was probably going to be able to join us today. So I will be giving you some information about him later if he joins us. But he's working in the south of Brazil, and he's working on a university, and he's trying to start this testing center, maybe related to specifically research or a combination of both testing that's ISO related or emerging technologies as well. In our meeting also, we identified as a group some of the issues and barriers on budget and local alternatives. And there were also advantages and disadvantages, advantages and facilitators, such as the space needed for testing and the expertise to do the testing. And finally, the areas to improve included the partnership and collaboration with experts and the development of tests that are more appropriate for remote and rural and Sandy and Marius regions. So I want to highlight that in consideration of the partnership and collaboration with experts, I have been reaching out to some of the testing centers and asked for presentations, feedback, and ideas to some of you. And this is how Bill Ammer from Ammer Consulting offered himself to present today on how to do the test dummy. So before I give the chance to Bill to talk, I just want to give you some quick updates on what's happening on our website. So this is our website, as you may be familiar. Our website is wheelchairnetwork.org, and the updates that we have worked on is on the Wheelchair Testing Centers page. So I'm going to show you how to get there. So once you get to wheelchairnetwork.org, you're going to come to product testing. You're going to choose wiki. And once you are in the wiki, this is the home page. So just go ahead and click on Wheelchair Testing Centers. And here you're going to see the list of the testing centers that we have included as of today, meaning you will be able to see the contact information of the person who is at ShonEquip or No Risk STE as an example. And on the right side, you will be able to see all the available tests on that center. Now, if you click on the map, and just for presentation purposes, I added the map on the right side so you can see both. So click on the testing centers map and you will have all the locations here. It's a little small, so I hope you can see that. But you can also filter by test. So if I click, for example, in determination of maximum speed acceleration, you will be able to filter that. And finally, you can just click on any logo and you will be able to, again, see the information of that test. So hopefully with this, we will be able to share more information about multiple testing centers and be easy to find, make it easy to find where they are and what test it's available. Finally, because we are still trying to reach out to more testing centers, we added a survey at the end of the Wheelchair Testing Centers page, as I'm showing you now. So if you scroll down to it, you will be able to see this survey. Again, for presentation purposes, is side to side. But if you will be able to help us sharing the Wheelchair Network page on the wiki, please help us to reach out to more centers. They will be able to find this form here and we can contact them directly also. So as part of this survey, they can fill the main information as their contact information, and also they can identify if they have ISO testing or the European standards or national testing, or also emerging developing testing methods. So these are some of the updates that I had for you guys for the wiki and the wheelchair testing centers. And I would like to ask you if you have any questions for me before I let Bill present.
I'll just add, thanks, Stephanie, and it's good to see this website evolve. That naturally, for those of you who do testing as a revenue stream, not just for your own products or just in general to support the sector, like donating test services to for chairs that are going to be used in less resource settings, that making sure your testing capacity is up to date on this will help us help you to identify people that you can work with. So I think that we're trying to build that. This is really the intent here, is to support you all in your testing. And so this is one way, but obviously we're very open to guidance on how we can
Mhm.
continue to support everyone.
Yeah, definitely. Thank you so much. Does anybody else have a comment? If not, we will be going with Bill soon. Okay, so now we will have the test dummy set up by Bill, and Bill, whenever you're ready, I will be switching to your camera.
Before we go out into the shop,
Mhm.
Stephanie, can I share my screen for just a couple minutes?
Sure, go ahead.
Okay. Where am I at? There we go. Okay. Can everybody see this PDF?
We are looking at a, yeah, it is a PDF.
Okay. All right. So this is a part of the RESNA standard. However, the ISO standard is very similar, if not identical. The two tables here, one is the shows the masses of the three body segments of the mannequin. We've been asked to use the word mannequin here in the United States as opposed to dummy. So I will use mannequin here. So the mass ranges are between 20 and 50 kilograms. And then there's a second one from between 50 and 100 kilograms. And the third one is anything greater than 100 kilograms on the mannequin. And there are formulas there for the mass of the torso, mass of the thigh, and the mass of the leg. I'm just going to run through this really quickly unless somebody has a question, but you should all be pretty much familiar with this. The original data that was done on the mannequins was based on the overall location of the center of mass. And so we are very confident with the overall center of mass in a seated position. And so these are the formulas for under 25 kg, between 25 and 100, and greater than 100. Once you've got your dummy put together, then you are going to use this fixture or some other method, but this is the referee method that was specified in the standard. It's basically a seat with all of the pieces at right angles, so that in order to find the center of gravity, you're going to tip backwards until you find a balance point. At that balance point, the center of gravity will be directly above the contact point on the floor. And then you'll tip it forward and find that balance point. And where those two lines cross, that will be the center of mass of the entire system. And then knowing the center of mass of the fixture itself, you can mathematically calculate where the center of mass of the mannequin is. So we'll go out to the shop now, and I'll show you how this how this all comes about. So I will stop sharing this screen. Where'd I go?
I'll do the spotlight for you now on the shop view, Bill.
Okay.
Yep.
All right, let me mute this.
In terms of a process, if there are questions while Bill is is doing this, I certainly suggest just add it to the chat, and when there's time during the demo, we can ask him those questions. So if things come up while you're watching this, please put it in the chat.
Thanks.
Okay, can everybody hear me okay?
Yes, we can
Yeah.
hear you well.
Okay, so this is the fixture that I was just talking about. Everything is at right angles. And this was the original chair, the original fixture built when we designed this system. So we're just using a digital level on the bottom here to find our angles, and we'll do a tip forward and back on this. Now, to set up the dummy for the mannequin, the first thing that you're going to look at is what we call a loading plate. And these are basically just plywood with a bit of foam on the back, one for the seat and one for the back. And this is designed to, let's see if I can get in the camera here a little bit. This is designed to approximate the size of the person. So the dummy that's designed in the standard is only about 15 inches wide. And so to accommodate a larger mass dummy, we've designed loading plates that will get the width that we need to spread that load out as it would be in a regular chair. So these would be installed on the seat. I generally attach the loading plates to the mannequin with screws through the back. Making these things out of wood makes it very easy to attach things to it. They're also much cheaper to make. I've had several of these dummies for over 10 years. They're made out of a marine grade plywood, and they've held up very well, and they're easy to repair if they get broken. So once the dummy is loaded, and this is something that you'll have to do in your own shop, depending on how your dummy is configured and how you're loading it to get it to the proper weight. This fixture is for the verification of where that center of mass is. So once your dummy's loaded and set up, so you'll set up and you'll tip your fixture until you find that really sensitive balance point where it will just about stand still on its own. And then you'll read that bottom ankle on the digital level. And then you'll also do that to the forward point. And find that balance point. And where those 2 points intersect, that will give you where the overall center of gravity is. If you have to adjust, let me grab one thing here. So in your verification process, let's say after you load the dummy and do your balance test, you find that maybe your center of gravity needs to move a half inch or an inch up or forward. We use, this is regular building material. It's foam insulation, it's solid, but it takes quite a bit of load to deform it, and there's almost no weight to it. So if you have to move this forward a little bit, you could use the building foam to move your center of gravity a little bit further forward or up if you needed to. And there's almost no weight involved, so you're not biasing your findings by very much at all. So the next step here is in the works right now, and the problem that we've found with this particular setup is that the center of gravity is only verified in the seated position. And the problem is that with so many complex rehab chairs right now, with tilt, recline, elevating leg rests, the center of gravity of the dummy isn't always verifiable for those situations. And so we're working on a new system that will allow us to generate formulas that will tell us where the center of gravity should be based on recline and tilt angles and leg rest angles. So are there any questions at this point from anyone?
I have a question, Bill. So when you move the mannequin forward, is that because you want to make sure that the result from your formula is the same as the one in your real life calculation
Yes.
for the center of gravity? Okay.
Yeah, so
Would-
I'm sorry, the
Would-
formulas in the standard tell you where the center of gravity should be based on this point right here, the intersection of the backrest and the seat. So if you fill your dummy with the weight and find that you're not quite where you need to be, you use the foam to adjust that center of gravity so that you meet what's in the formula.
Thank you. And will you do the same at the bottom of the test dummy?
Yeah. Yes. So in that case, it gets a little tougher. You have to lift the dummy up and put that foam in there in order to do that. Most of the time, I just keep playing with the weights in the framework of the dummy to try not to have to use that foam, but occasionally you do.
Okay. Bill, we also have a question from Peter Axelson from Beneficial Designs. He
Okay.
says, Bill, would you estimate that the amount of weight distribution should be distributed 60% to the seat and 40% to the torso? So when the recline occurs, 40% of the weight will move with the torso. This would appear to be more accurate than the non-weight of moving back for the amount over 100 kilograms. And Pete, if you want to add to that, feel free to unmute yourself, no worries.
Well, actually, what I'm finding is that if we look at just the torso, and when I say torso for this application, I'm talking about the head, the arms, and the entire torso. That actually accounts for about 60%, a little more than 60% of the total body mass. The thighs is, trying to remember now, 20, mid 20%, and then the rest is in the lower legs and the feet. So if you're putting 60% of the weight in the seat, it may come out in this fixture. It could come out that you have the center of gravity right, but as soon as you tilt or recline something, it's probably not going to work. It's probably not going to approximate that. Putting the extra weight in the seat was done in the original setup just to, I guess, make it easier to develop those formulas, but the current formulas for the individual centers of mass of the body segments, I've found them to be inaccurate. And so that's why we're working on this second generation of the dummy and the verification.
Bill, I have a question.
So
Oh,
Bill,
go ahead. Sorry, Peter.
Until we can confirm exactly what it should be, are you thinking maybe like 65% should really be added at the torso and
Yes.
and then, yeah.
Bill, I wondered if you can talk about the consequences of not making this adjustment and what tests it has the biggest impact on. And I think about a couple of aspects of this. First of all, sort of internal consistency with your own testing in a particular lab, as well as consistency across lab results. I mean, in an ideal world, I test something, you test it, Don tests it, Shona tests it. We all get the same result. And so I want maybe to have you emphasize the importance and where you think not tuning this center of mass could have the biggest impact on what tests.
The two main ones would be static stability and dynamic stability. Maybe static more so than dynamic. The problem, I could set this dummy up so that, let's say I'm doing a 100-kilogram dummy. I could set this up with most of the weight in the seat section here, or I could set it up with most of the weight in the torso section here. But in both cases, in either case, I could still meet the center of gravity requirement that's specified in the standard. The problem happens when you start to move things off of this 90-degree reference point. So if you put too much weight into the lap section, rearward stability would show up as a greater number, because you would have too much load here, so that when you tip this back, it would actually tip back farther than it would if you had more of the weight up here. Does that clear that up, John?
Yeah, and so I think in the case of the types of products where for static stability, you need to do least and most stable conditions. And if you have recline or tilt, then this center of mass location is really important of where the distribution of mass is, because and I'm just sort of elaborating, but tell me if I'm wrong here. Like if you have a lot of weight up in the torso and then you recline or tilt, then your result's gonna be a lot different. That least stable rearward tipping condition, you're gonna show that it's much less stable than somebody that's got a lot of weight in the torso, or sorry, in the legs.
That's right.
So I think that's where it's a really, one of the things I think for the group is to understand where this type of tuning of the dummy and understanding where the CG is and the distribution of mass in general becomes really important. Is that you have a pediatric product, tilt in space, or something with recline, you're going to have a very different number depending on where the distribution of mass is in this dummy.
That's right. And one of the reasons that we're doing a second generation on this is because of just that. We've had test labs that have done the test with the dummy and then done the test with a person of that size. And once they go into like a tilt recline, the measurements are off by as much as 10 degrees.
Now, can I just ask a question too? Because when we're working with quadriplegic with a high back system and head support and other postural supports onto the chair, the dynamic changes significantly, especially if they're tall. So, yeah, I'm actually
Well,
getting more confused less confused now.
Um, Well, part of the problem is that we cannot account for all body types. If any of you remember the original test dummy that was developed in the ISO standards, it was 100 kilograms. And back 20 years ago, all testing was done with 100 kilogram dummy, regardless of the capacity of the chair. And the original dummy was designed with no leg section at all. And it was purposely designed with a heavier torso to represent a manual wheelchair user whose lower extremities had atrophied and whose upper body had become more developed because of pushing a wheelchair. However, those kind of things really only apply to manual wheelchairs. And you know, when you start looking at power wheelchairs or scooters, you don't necessarily have those kind of body types using them. And so it's more of a, I want to choose the right word here. The body hasn't made major weight changes like it would for a manual wheelchair user. And so we had to pick some sizes that we thought would cover the most people, and build our formulas on that. So when I started to develop this system, the tolerance on the dummy, I think, is plus or minus 5 kg. So I found every person that I could that was within that 200 kilogram weight class, and I measured their CG and used those numbers to help develop the original formulas for the overall CG.
I think this question, what Shona brings up is a really important point, that at the stage when, you know, if you read on the documentation, this is how stable a chair is, that's using a standard dummy and not necessarily accounting for the weight distribution of the client naturally. But what becomes even more of a problem is if the dummy setup is different for the test lab that's, you know, actually generating the data for the brochure and for the specifications of that chair, then, you know, anybody using that chair is unaware of really what the true stability is. And so
Right.
test labs should be reporting the same stability using a standardized and predictable dummy.
Yeah.
But at the clinical provision side of things, you have to account for differences in your client versus the dummy distribution.
Yeah.
And it's also the setup of the chair changes the dynamic of where the weight distribution actually goes. So, I mean, we're finding with different types of users in different setups, different parts of the chair show obviously different wear and tear. And I'm sure we're all experiencing that same thing. And I'm just wondering, how the hell do you test for that? And I'm wondering if Bob has some ideas here. Because, I mean, children testing and quadriplegic testing for quadriplegics is very, very different from an active wheelchair user. And And yet the wear and tear on the chair is going to be different because of the setup. It's not even so much about the dummy. I think the setup with the combination of the dummy becomes the challenge.
Yeah, and you're correct, right? So with static stability, you test the the tipping angle of the chair in all directions in both least and most stable conditions. So you essentially have the limits in all directions, laterally, rearward, forward, and sort of get the limits of whatever the chair setup may be. The wear and tear, so you do get sort of this envelope of information on worst and best case scenarios. But the chair setup related to wear is a really important point, which is that the wear, the section 8, the testing, the static, dynamic, and fatigue strength testing is done in a particular neutral position. And so that is where I think certainly we could spend hours demonstrating different ways to set up a chair that fit within the standard requirements, but result in a different outcome on the fatigue tests. And I think the number one way that people help a chair past the double drum is to change the caster diameter and change the loading on the casters. So I think your setup point and the wear and tear is incredibly important. And another reason why there just needs to be more standardization in how we perform the tests. There's a lot of room for interpretation with the test setup, especially related to these the fatigue testing. That's my opinion. I think I'd be interested to hear Bill and Don and Peter's, the team in Peter's shop, about that.
I agree with you on that, John. There's I have the biggest test problem I have here in this shop is testing a manual chair on the drum test. Because a lot of times I end up with backwards loading. I end up with 60% of the weight on the casters and 40% of the weight on the rear wheels. And, we just destroy casters. So knowing where the center of gravity of that dummy is really important for that test. For a big powered chair on the drum, I think it's much less critical where that center of gravity is. Because in a lot of cases, the dummy is just about equal to the weight of the chair in some cases. And so it doesn't have that big of an effect. But getting it right on a manual chair is really important. And the CG formulas that are in section 8, ISO 7176-8, -11, are based on people that were actually measured in a seated position. So, which is, unless it's a chair that's got really outrageous different positions, the drum test is usually carried out with the dummy in a seated position. And so that center of gravity, I'm confident in those formulas that generate the CG requirements for the dummy. I'm confident that those are good. Based on like a 90th percentile human being.
Thank you, Bill. I think that might be responding some of the questions that we have here, but I will share with you the questions now. So one is from Stephen Peters from Beneficial Designs. Has a center of mass study been measured with actual persons in a reclined configuration?
Okay.
And the second one is from Bob Appleyard. He's saying, is it that the test dummy is primarily used for durability testing?
Well, I think the dummy was originally developed to use for the drum test and the drop test. And I think, you know, back 20, 25 years ago, when these standards were developed, but still pretty rudimentary, doing static stability was almost always done with a person. So if you had somebody who met the weight requirements, there are even provisions within the standard that says that you can add weight to an actual person. But there was never anything that told you where to put that weight. So in a lot of cases, for doing static stability, if you needed a 300-pound person and only had a 200-pound lab technician, the extra 100 pounds would go on the seat underneath the person in the chair. And so that that would totally bias the center of gravity requirement for how that chair should be configured. So, and the same thing with dynamic stability. Most of that dynamic stability testing was done with a person in the chair. But number one, I think it's a little dangerous to do that testing with a person in the chair. You can't keep that constant from lab to lab. So trying to develop a set of formulas that tell you where the center of gravity is, if it isn't totally accurate, or if it doesn't meet every body style, it's still better than having random results in 10 different test labs. If you can get everybody to test with the same dummy and the same center of gravity, then you're better off as a whole.
Thank you, Phil.
Was that Cooper's Bane?
What was that?
Was that Cooper's Bane? Cooper's Bane. It was. I remember Rory Cooper was responsible at one time for the development of what became Part 11, and I think that the calculation for the center of gravity for the heavier occupant ended up with a center of gravity below ground level, which made us all smile. But I think that he put it right, of course. But
I remember that. You know, when I came up with the current set of formulas, it came about because I had the appropriate test dummy in a scooter, and I was doing dynamic stability. And at the time we were testing 100 kilograms, which I meet. And so the scooter would pass with me in the scooter, but with the original test dummy, it would fall over backwards. And so I started to measure people, and I found that the center of gravity of let's see, it would be the dummy in the 1998 RESNA standard. The center of gravity was 3 inches too far back, and it was about 3 inches too high. Again, it was that setup where we were looking at someone whose lower limbs had atrophied and their upper body had developed. So that prompted us to develop this new set of equations. Does that answer your question, Bob?
yeah, kind of. I suppose it's really kind of, we're in that benchmark testing place, aren't we? You know, with the actual real user setups or something else. We're kind of creating a basic level of stability with a known kind of occupant mass dimension proportion, which
Right.
is used to, you know, provide a list of tables perhaps, or comparative data for a purchaser or a a procurement body that would be looking for basic levels of compliance to standards, rather than final bespoke individual solutions.
Just as a bit of an aside, and I know, Bill, you're continuing to plug ahead on this dummy work. We have a new faculty member. His name's Clive D'Souza. He moved from University of Michigan, but previously he was up in Buffalo, and he was part of a fairly large effort to collect anthropometrics from people with disabilities, I think primarily wheelchair users. Perhaps, I don't know for sure, but perhaps there's some of that data set that would be helpful to you. I know it was collected years ago, but I just wanted to let you know, and I can, when I meet with him next time, I'll ask him about it. But I know he continues to get requests to do some analysis on that data set from the Access Board and others. So, so yeah, I think in helping to adjust this moving forward, like we might be able to help a little bit.
Yeah, that would be great. I see there's another question here from Bob Appleyard about posture change. That's 717632, I think. That was published 2 years ago, I think.
Bill, do you know, I got a feeling that 32, I'll have to check. Wasn't there one of them about batteries, or was that 31? Yeah, okay. Well, has it
No,
completed?
it's not 32. Oh, I got my numbers confused now.
I'm just wondering.
I think 32 is casters, right?
Yeah, 31 is batteries then. Yeah. So I just wonder if that project actually got guillotined, or was, kind of fell off.
The posture change?
Yeah.
No, it's published.
Oh, right. Okay.
I'm looking it up here right now.
Because that would include stability issues when,
I'm sorry.
That was activated.
Dash 30 is posture change, 7176-30.
All right. And does that give kind of more details about shift of gravity and the location of a center of gravity as tilt or tilt recline takes place, with limitations?
No, it has no reference at all to center of gravity in that. It tells you different configurations of the chair to do things like drum and drop, static stability, dynamic stability, but it has nothing in there about where the center of gravity should be.
Well, I don't know what to say, really.
I'm going to head back into my office.
Thank you so much, Bill. And in the meantime, I will be sharing my screen again. So let me come again here. Okay. Well, thank you so much, Bill, for your presentation, and everyone who asked questions as well. So now we will have quick questions from a new testing center. And before we do that, just because we're getting short in time, I will be putting a poll on the screen for all of us. This will be really quick, just 3 questions that we can determine how we will proceed with our common meetings. Okay, so please let me know if you can see the polls right here on your screen, and please feel free to choose. The first one is, when do you think we should meet? So I have placed different options, such as second week of October, second week of November, the second week of December, or finally, if you prefer to move it to next year in January, the second or third week of Jan. The second question is, do you want to present a new topic for our coming meetings? You're free to say yes, no, or maybe, and we can be in touch later on what topic you would like to present. And I have noticed that in our previous meetings, we are running short in time. So I would like to propose if you would like to add 30 minutes to our next meetings as well. I will give you guys a couple minutes before we continue there. Okay. So far, it's looking like the second week of November is the winner. And we have 4 tentative presenters. Okay. Let me see. I will give you guys 30 more seconds before I launch the results for all of you. Okay, sounds good. So here are the results. The winner is going to be the second week of November. So we will be sending you an invite again for Wednesday, the second week of November. And then we may have some presenters. We have a divided group. Some of them say no, and some of them say yes. Well, maybe they would like to present. And finally, it looks like, yes, we want to add 30 more minutes to our meeting. So I will be updating this in our next meetings invitations as well. Thank you everyone for your answers here. And I think that for now, since we're running out of time, I will just share maybe 1 or 2 questions, and then I will give room for people to open to discussion. If you guys want to stay a little longer, you're welcome to do so. So some of these questions came from meetings that I had with more than one testing center or people who were interested in creating the centers. So I will be sharing the first question, and that is, what machines or tests do you start with when you're creating your testing centers? And please feel free to unmute yourselves and if you guys want to share your experiences with us. We don't have any volunteers today. Thanks, Bill.
Are you asking for answers?
Yes, I was asking for answers.
Okay. I started with my drum and drop because they were the most involved to build. And I wanted to get those done. I actually started from nothing and was in business inside of 6 weeks. But the drum and the drop were the biggest challenges.
Okay. Thank you. Now, I will continue with the next question. And that is, how much space should I consider for a testing lab for a manual or power wheelchair tap?
How much? Did you repeat that? How much?
How much space, like how much area should I consider for a testing lab for manual and power wheelchairs?
Is that during conducting durability tests, the range, theoretical range of, because that's quite a spacious.
Yeah, like if someone
old.
would be creating their own labs, how much space would they need to consider to start putting together the machines and etc.?
I have 3,000 square feet. And I could probably use a little more, but I make do. I can do the range test inside my building, and I just make the minimum. I think the requirement is no less than 50 meters around. And I think my indoor track is 52 meters. When I have a big parking lot out in the back that I can run range on. But if you're going to put a ramp in for dynamic stability, the minimum recommended for that is 3 meters wide and 10 meters long. That takes up a lot of real estate if you're putting it in your building. So you have to use it for other things. So I do, like on my large ramp, I've incorporated obstacle climb, and I do all of my Section 5 measurements in a corner of that ramp. So if you make things do more than one duty, you know, you might be able to do less, but yeah.
Okay, thank you so much. I think that just because I want to be respectful with everyone's time, I will just jump to our thank you. But if you guys have anything else, this was a quick slide just to remember that last meeting, we just thought about meeting every 3 months. We would like to stay connected and we want to help other testers and also clarify how to do tests. So Bob, definitely your text to the group about doing something related to the crash test is more than welcome. And I will be in touch with you soon. And finally, I would like to thank you all for joining us today, especially Bill also who was presenting today. And I would like to invite all of you to also do a presentation on any test you're doing, and let's keep connected. Thank you so much, everyone. And I'm going to stop sharing right now. I will be staying on the call for a little longer. If you would like to have something added or ideas, please let me know. Okay, thank you. Okay.